Hello everyone. Today we will look at the new features of the script type. In fact, there have been quite a lot of new updates accumulated there, which we will now go over. But before we get into all of that, actually, I've already talked about this for a long time on my Telegram channel. So to avoid missing a good opportunity to get information first and to have a chance to participate in contests, right now there's actually a contest going on there for Telegram Premium, as well as the opportunity to get additional information. Cheat sheets, advanced materials. The link to the Telegram channel is in the description. Go to the description. The very first link will be to my Telegram channel, so subscribe. And now let's start looking at the new features of the script type. The first thing we look at is, in fact, more convenient type narrowing. As we can see, here we have order 1, then order 2. Next, in type C, we have one of these types. After that, in the myFound function, we check whether our field H is present in our type C. If it is present, then accordingly, our C must be of type order 2. Previously, there were quite significant problems here. Now, however, we can see that our test here suggests that we want to select either H or type. In other words, we have narrowed the type down to our order, which is undoubtedly convenient. Next, actually, this is a very common mistake among beginners, and not just beginners. When we check our number for NaN, in the past we didn't really understand, roughly speaking, how to check for it. Well, we did understand actually, but we could get confused. But now, our test actually suggests to us, did you mean number is none? So, in fact, more convenient hints are making our lives easier. Next, one of the super interesting new features in TS is the using operator. In fact, those who work with languages like Python or C know what we're about to talk about. If you know those languages. To clarify, I'll say that it's something similar to context managers. Let me explain what it's about. Previously, when we worked with files naturally, when working with files, for example, socket connections, working with servers, and basically anything that requires explicitly closing a connection, a file or something else, in the end, we could either close it, forget to close it, or simply miss that step altogether. Previously, it looked something like this. That is, we would declare our variable, then read some file, and after that, we had to close it. In any case, the file gets executed regardless. So we could perform the closing operation here, but sometimes we could simply forget to close it. In other words, some people write code without any try finally at all, just like this. Which you'll agree isn't quite correct, because at some point we might forget to close that file, and as a result end up with a number of errors and issues. But now we have a different situation. A new operator, using, has been introduced, which gives us the following advantages. First of all, to begin with, we now have such a thing in Sambal as dispose and async dispose. Dispose is used for synchronous interactions, while async dispose, as you might guess, is for asynchronous interactions. Here is our function, and you can see what it looks like. We have our getFileHandle function, where we take our file, read it, and then what do we return from our function? We return our file handle, that is our file. In addition, there is the async dispose symbol, which indicates that when we stop interacting with this file, meaning when our code continues executing further, we will close it ourselves. So basically, here we have read our file, getFileHandle, we've read it. After that, we can do something additional with the file, retrieve something, interact with it, get data, and so on. And then, at this point, we can write something here or add any other additional logic. In this case, our file will already be closed. In other words, we simply closed it. It closes automatically for us. The context manager works on the principle that without explicitly closing a particular file, we tell our language that at the moment when we move on to further interactions in the code, we should close this file. In this way, we make our lives easier. This using is written before our file. This is like let, var, or const. Roughly speaking, it's a similar story. Only using indicates that this variable will be disposed of, that it will close a particular file connection after we've interacted with it. As we understand, if we want to interact with something synchronously or synchronously read files or anything, we simply remove the async pause, we simply write a pause. This way, our interaction becomes simpler. It won't work everywhere right now. Here, you need to properly update your script with Node and make sure everything matches up. But this feature is one of the new ones, and it's very useful and convenient, and it will be used a lot, many times. There you have it. Continue watching. I highly recommend you check the description, go to my Telegram channel, and subscribe, because the newest, most up-to-date, and first information always comes out on the Telegram channel. There I run polls to decide which technology we'll review next. There will also be contests for free consultations and so on. There will be lots of new perks, so go to my Telegram channel and subscribe. Next, one of the interesting operators is the satisfise operator. What is it? Satisfies, or satisfying a certain condition, solves one main problem. Which one? Let's imagine we have a person info, which matches, and inside it we have person name and other details. Other details is an object that contains ID and age. Person name is a set of names that we accept. It's either John, Jack, or Justin. Okay, we have person info, person name. After that, we want to create our person type. In the person type, we'll have the fields my info and my other info, where my info is person info, which is what? Either person name or other details. Okay. My other info is person info, which is also either one or the other. So in fact, we don't really know what will be stored here. It will either be our names or our little object with ID and age. Okay? Okay. And when we define the type in our usual way, when we write our colon, we specify our person. Okay, we've specified it, but then what? What happens next? We write application myinfo and see that in fact we don't really understand what we're working with. And again, the same story my other info, and we don't see our fields ID, age, and so on. What's happening here? When we specify our person type for our applicant, basically, two small objects were saying that this type will fully satisfy, or rather this object will fully satisfy the following type. What does this mean? It means that the current definition, the current type we have, gets overwritten by the one we specify here as person. How can we fix this? Naturally, when we work with person like this, well, we can't really. Either we narrow the types, but that's not very convenient. We need to somehow narrow the type and add checks. Why should we do that when we have satisfies, which takes our person? Let's remove this thing. And what does it say? Okay, we have the current type, so in my info there will be some John. Well, like John, Jack, Justin. So this is a string type, and roughly speaking, it will match. My info, here's the next situation. We're saying that, okay, fine, it can be there, but at the same time, it must fully comply with person. As we can see, it matches person. So my info is either person info or person name or other details. This correspondence exists because we have John, who is part of person name, which is part of person info, and which is already included in person in my info. So in fact, we're saying that we're satisfying the condition without overwriting what's written here. If we have a string here, we don't want to see the toString method, since it's already a string. If we have an object here with an ID and age, we don't want to see toString there, because it's not toString, we want to see either the ID or the age. What do we see here? When we write satisfies person, we see the following situation. In my other info, we write and see age and ID. So in fact, we are not overwriting what we have written. This way, we make our lives easier. And one of the most interesting and significant updates is the work with decorators. As you can see here, I wrote two different ways to use decorators. This is our previous way of working with decorators. When we have some function, well, we might not need to define it if we want to accept some argument or pass a prefix, but in any case, we would define that in the wrapper. If not, then we specify the target, prop name, and descriptor. Depending on where we apply this decorator to a class, to a property name, to a method, or to a setter or getter, we combine these three values in a certain way. If it's just a class, we use the target. If we have a target and a property name, for example, if it's some attribute, then we use both the target and the property name. And if it's a method or a getter setter, then we actually use the target, the prop name, and the descriptor. Okay, we can see here how this works. The target is a reference to our class, where roughly speaking, we are applying our decorator. The property name is the name of our method or attribute. The descriptor, in turn, is the object that defines how our method will exist, meaning what its value is, whether it is enumerable, writable, configurable, and so on. Here we can see how it used to look, the low class and so on. How does it look now? Now it looks as follows. They removed the interaction with remove that third designation. That was an experimental feature, now it's more stable. This is what it looks like, and the target is our function. If we apply this to say a class, then here we will have the class. The context is the context What is that? In the context, it's specified whether it's a method, a class, or what exactly it represents. Some additional information, we'll look at that later. What's next? Next, we have direct interactions with our internals. That is, we get to do something there, but that's not the point. Let's move on to the method. This will be more interesting. Why? Because the method, first of all, has self, which we accept here, and arguments, which we also accept here. So basically, we pass this along and call it, and we can see that this is how it works. Let's first take a look at how the old second way of working with classes looks, and then we'll move on to the new way of working with classes. So we see that here we have version 4.9.5. Of course, it's not necessary to choose exactly this version, but just to see what we get in the logs, let's take a look. Run. First of all, what do we have written here? We have a user class of some sort, which has a public name string, a constructor that takes our name as a parameter, and a decorator on our getData method, which returns our name. In our username, in our Alex here, we create a user, he will be Alex, and then we call getData. When we call getData, accordingly, we trigger our log decorator, the decorator method, and as a result, we pass a prefix here and expect that it will be Alex. Okay, good. After that, let's see what's happening here. Our method simply returns the name. We go into the logme decorator method. We come here and see first we initially get our descriptor value. By getting the descriptor value, we don't just get, well, I don't know, some value, we get our actual method itself, meaning the method that we will call further on is stored in original method. After that, how do we override our method? We create a new function and essentially assign it to the descriptor value. Next, we do some log start, log end after, which we call our method, get the result, simply pass it on, and then return the descriptor. So in effect, we have rewritten our method and wrapped our getData method with these logs. So we will have these logs. Here's log start, log end, and as we can see, so log start, method that will come next, but here log start prefix, the method we received, and log end prefix method. And then we get Alex. So basically right here we'll have accordingly our result. Well, let's even get some kind of result. Let's make a consultation log to make the result clearer. There. Now, let's just clear all of this. Let's take a look. There we go. We see that Alex is output inside, so we've displayed it. The same thing, but for class decorators. In class decorators, as I mentioned, since we are working specifically with the class, we have one parameter or constructor, rClass. Well, that's the prefix. After that, how can we get our method? How can we actually access it? All the methods that a class has, which we provide to our class instance, are passed through the prototype. That is, our getData will be located in the prototype. Accordingly, to access it, we get our descriptor in other words. We obtain the list of our methods, the property descriptors. After that, using object entries, we iterate through and retrieve them. Let's take a look. First, we check whether our value is a function. If it is, great. But is our value a constructor? All right, if it's not a constructor, then it's also a method. Okay, what comes next? Next, we have exactly the same process because we take our descriptor's value and create a local start for the method here. We see that there is a log start for the getData method, then we get the result, then we call our method, log end for the method, and return the result. To make all of this apply to our specific method in our class, we use define property. And here we specify the constructor prototype, take our key, which will be our getData, and in the descriptor we have our value, enumerable, configurable, and so on and so on. What's happening here? We're simply overwriting what we had before. In other words, we are overwriting our method accordingly. Here we can also try to do a console log. So console log result, and let's see what we get here. From class decorator, we run it and see this. We run it, and see what's happening here. Our method's login was completed, and after that, the login for the entire class takes place. Next, we have logend for the method, as we've specified here, and we return the result accordingly. That's how classes used to work. So we see the classes. Let's go through it again. Target is, roughly speaking, where our decorator is being applied. Context is the context around it. That's where, I don't know whether it's a method or not, but we'll look at the info further on, and then we have exactly the same sequence of actions. It's the same with the method. Let's take a look again. Here we have, well, I didn't bother with prefixes here because it's actually the same thing. We just wrap the function and then pass it along. So there's absolutely nothing particularly new or complicated here. The same thing applies if you want to pass some parameters. We wrap our function in another function and basically return it. Let's do some kind of fun. So function, what did we call it here? Log class. Log class. Here we'll have a prefix, a string, then pam, 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 pam. Everything is the same, except here we'll pass in some kind of prefix. Hello. And in the info, let's do something there as well. All right, let's change it to look like this. And let's have our prefix look something like this here. Prefix. Bam, bam, that's it. Let's take a look. We can see that our class is exactly the same. Next, we have absolutely no changes here. Now let's see what will be out. First, let's run it. The first thing we see is that the info is happening. Where's this info coming from? When we call our getData, the first thing is that our user class is being logged. So every time we access our class, our log will be triggered. That is, the first thing that will happen is that we will get a prefix. There should be a prefix here. We see that hello is our prefix. Well, initially, it's actually the context of our method because we first called the method, but then the login of our class also happens. So in fact, at first we see the context of our class in which we specify actually, I misspoke the method. Let's move on to the method. In the method, it says that in the info, in the context, we have kind, method, name, getData. Is it static? No. Is it private? No. Is it some kind of access method? It's just additional information. So what do we do next? We return a function that takes this and args as parameters. This, as we understand, is simply our context, and args are just the arguments. After that, first of all, we do some logging, then we run our function, and here we also use call, passing in this and args, and it also returns the result. So basically, there are almost no changes at all. Only the way it's written has changed a little, but overall, there are no major changes. We can see that here it logs start for method getData, and the log for the start of the method here will be for getData. Next, there's a log for start for method getData. Where does this come from? Or rather, this comes from the class, this is our class, this is our method, this is our method, this is our class. All right, log start, let's call it method here so it's clearer because it's not entirely obvious what we're outputting here. We're just cleaning this up now. Output it. We see that the method is also being output, and here we wanted to use our result in the console. All right, log res. So res is. We do it and we see that our changes have also been applied here. If we want to do, for example, res +1 here, if we want to do that, we see that Alex is being returned, but not just Alex. Here we log that we just have Alex, but here we have res +1. And in fact, here it won't be Alex, but Alex1, we can see that this is what's happening here. That's how it works. The same applies to classes. In classes, the first thing we have is the target, which is our class. The context is the context of our class. And specifically, we see here the kind is class. The name is whatever it is, and the metadata is whatever it is. Well, we don't have any metadata. After that, here we also get our methods from the prototype in our target, then we iterate over them and check if it's a function. Okay, it is. Is it a constructor? It isn't. So using white, we get our value, assign a new function to it, which basically means we overwrite what we have here from, we add some logging, specifically log start for method and log end for method, and we return the result. If we wanted to add, say, 1 to the result here, we did it and got our Alex1. Well, let's remove it now and let it be 2 ones even. Well, this many ones. We can see that we're getting them. So that's how classes work in the current expression. These are the kinds of changes in TypeScript, and actually there are a few more of them. Because if you look more into the TypeScript documentation about how it works now, there are some new additional interactions with types, more narrowing in some places, fewer errors in others, and better performance elsewhere. But I'll be writing about all of this on my Telegram channel. So go to the description and subscribe to the Telegram channel. That's basically it. We've covered the new features in TypeScript. Let's stay in touch. Subscribe.